What's up my friends, welcome back. In this video we'll see how to control this. This is called a Nixie Tube, and we'll see how to make the circuit to get the high voltage, because this works at high voltage around 200 volts. And for that circuit we'll see the driver that we need to use to boost up the voltage, and then I will show you how to use some BJT transistors to control it like this with the Arduino, but even a better solution how to use it with some drivers and control 4 at the same time, because I'm planning to make my own watch like this one, but instead of an OLED display I want to use this. These are Nixie Tubes. So this will be like a retro vintage watch that you could wear on your hand. So guys, stick around in this video because I will show you how the Nixie Tube works, how to control it, how to make it a high voltage, how to connect the driver to the Arduino, and then I'll explain you the parts that I need to make my own watch with Nixie Tubes. So guys, let's get started. Video sponsored by GLC PCB. They have services for PCB manufacture of 2, 4 or 6 layers, starting from only $2 for 5 PCBs of 100 by 100 millimeters. Other services are the stainless steel stencil for soldering with solder paste, and the SMT assembly, where they will solder the components for you automatically using high technology machines for a professional finish. So just go to glcpcb.com. Upload the Gerbers, select what you want and place the order in a couple of minutes. What's up my friends, welcome back. Today we'll take a look at this component here. This is called a Nixie Tube, and this is rather an old technology, it's very retro, vintage, whatever you want to call it. So in this video I'll try to show you how to control this and how this works internally, the physics and the electrons, how to make that glow for each number. And then I'll try to show you a schematic, a circuit to create high voltage, because this works at high voltage around 200 volts, so that might be a little bit dangerous. And then I'll try to show you how to control this with some BJT transistors, but also with some drivers together with the Arduino. And everything, all this I do because I want to prepare a future project. If you remember, this is my smartwatch, and this uses the Arduino, a real-time clock and an OLED display to show the time. The idea is to make this exact same PCB, actually not the same one, but the same circuit with the real-time clock and the Arduino, but instead of showing the time on an OLED display, I'll try to use Nixie Tubes. So for that I'll have to use very small components to fit everything on the PCB, and also be careful with high voltage, because you don't want high voltage near your hand, because that might be dangerous. So we'll have to make this protected, insulated, and with a case. So the idea is that in this video I'll show you how this works, how to control it, how to make the circuit for high voltage, and then how to merge everything together to be very small with the drivers and the Arduino and place it on your hand. And the idea is that maybe I will use 2 of these or 4 of these in order to show the time. If I use 4, I can show the hour and the minute at the same time, but if I use 2, I'll have to show the hour, blink, and then show the time. But that will be very difficult to understand. But anyway, this is almost 5 centimeters tall, so imagine that if you have 4 of these on your arm, that will be a little bit big. So maybe I'll use 2, but I'm not sure about that. So anyway, let's start, and first I'll show you how this works internally. Okay guys, so in a moment I'll show you how this works internally, the physics and the high voltage and how to create a glow. But first let me show you how I get this. Actually I bought this. It's not that easy to find this nowadays. I bought it from a guy in Russia from eBay, and it's not that cheap. Actually I paid like 45 euros for 6 of this, and as you can see it has that vintage look, even the case, the cardboard case, like a Soviet Union look. And these are used, as you can see, are desoldered from old vintage component electronics, so these are not new, but it's the only one that I found. This is this small, only 4.5 centimeters tall and 1.5 centimeters wide. So as you can see, they ship it in this protective foam, and I have 6 of this. And he also gave me 6 of these lamps. These are high voltage halogen lamps that you could use with the same circuit of high voltage. So let's see how a Nixie Tube works internally. Okay guys, so let's understand how these Nixie Tubes work. So this is the internal structure. We have our tube, which is vacuum, also almost vacuum because it's very low pressure, but it's not fully vacuum. And inside we have some gases, which usually is neon, with mercury, maybe with argon. Anyway, we have some gases that will create some reactions, some current flow, some electrons and ions, which we'll see next. But anyway, we have our tube, and inside the tube we have some cathodes, which are made from some metal wires in the shape of the numbers that we want to show. And by the way, these numbers are not touching each other. Between each number we have some mica insulators, which is ceramic, so we don't have connection between the metal wires. And these wires, by the way, this is not a filament as in the incandescent light bulb. So the light that this will emit is not because of the heat as we do in the incandescent light. This is because of the current flow, which we'll see in a moment. But anyway, we have our cathodes, which is the wire in shape of the number, and the anode is the case around the numbers, which usually behind the numbers the case is a fully metal sheet, but in front of the numbers we have some like a mesh, because we also want to see the light through this mesh, the light that's coming from the numbers. So as you know, from LEDs you place positive to anode, negative to cathodes, and then something will happen. So basically this is the structure of the Nixie tube. We have our tube, our enclosure with a neon gas inside. We have some pins connected, one pin to each of the cathodes and one pin connected to the anode. And the cathodes are not touching each other inside. So that's all the structure that we have for our Nixie tube. So let's go to the next one. Okay guys, so now we know the internal structure, but how this creates lights? Well, as you know, this works at high voltage, and we apply positive voltage to the anode, which is the metal case, and then we connect ground to the cathode inside, which is the metal wire. And that high voltage will create a voltage differential high enough that will split the gas inside into positively charged ions and negatively charged electrons. And it's obvious that the electrons will go towards the positive side, which is the anode, and the ions, which are positive, will go towards the cathode, which is negatively charged. And when the ions will hit the metal of the cathode, will break down even more electrons, and those electrons will get back to the anode, which is positive. So that will create some sort of current flow towards the anode. And here, as you can see, from the cathode to the anode, when the electrons hit with the ions, will create light. And that's the light that we see. And actually the light is not on top of the cathode, as you can see, but is from a few millimeters, which is called the Aston dark space, this here, because the light is not created on top of the cathode, but where the electrons are hitting the ions, which is from a distance from the cathode. That's why when you see the glow of the number, the glow is not on top of the metal wire, but is a little bit on the side, maybe a 1 millimeter on the side. So that's basically how we create light. We apply high voltage, we split the gas, the ions will go to the cathode, the electrons will go to the anode, and when they collide, they create light around the cathode. And when the ions hit the cathode, they will break even more electrons out from the metal, and that will create a current flow towards the anode. Pretty much that's the idea. But let's now see how to create each character separately, because we have to apply positive to one side and then connect separately each cathode to ground. Before I explain the connection and how to control this, let's just see an example. Here I have my circuit that I will explain in a moment, and this will create around 180 volts DC, and that is connected through a resistor. To limit the current is connected to one side to the anode of the Nixie tube, and now with this wire I can connect the ground to each of the cathodes. So let's see what would happen. As you can see here, I'm connecting it to the 5, and the 5 cathode will light up. Here I have the 3, the 9, 6, 2. Let me just make a zoom so you can see the glow here. Okay, so let's do this again, but with zoom. Here we have the 9, 8, a decimal point, number 2. I'm not sure if I can focus inside. 6. The 6 is not fully lighting up. Anyway, the main idea of this is just to apply high voltage and then control where to put the ground in order to light one digit or the other one. So now the next step is to see how to control ground on each of these pins, and also see the pins of a Nixie tubes. So let's go to the next part. So first of all, usually a Nixie tube has 11 pins. This one has 13 because we have to control numbers from 0 to 10 to 9 actually, so those are 10 pins. Then we have one more pin for the anode, which is this one, usually is marked with an arrow, so you have to see the arrow in order to know which one is the positive, which is this one right here. So with that we have 11, but this specific Nixie tube also have 2 digits for the decimal point. So we have a point here and another point here, so that's why in this case we have 13 pins. So from 0 to 9, those are 10 pins, then we have 11 with the anode, sorry, and then 2 more pins for the digital point. So yes, if you want to know the pins of a Nixie tube, the arrow will mark the positive one, and then you have to see the schematic or the symbol of your Nixie tube, and if you don't have the serial number, you have to go and test each one separately and write that down on a piece of paper in order to know which pin will go which number of your Nixie tube. So now let's see here the symbol and how to connect this. So guys, as you have seen, by connecting ground to each of the cathode, we can light up each of the numbers. So usually you will see for the Nixie tubes this symbol of this one, usually is this one here. So we have a metal plate representing the case of the Nixie tube, which is connected to the anode. Usually we use a resistor to limit the current from the high voltage to a few milliamps, so we don't damage the internal connections of the Nixie tube. And then we have one pin output for each of the cathodes. So all you have to do is to connect one cathode to ground, and that number will light up. The easiest way to do that is using BJT transistors. In this case are NPN transistors connected directly to ground. So usually the BJT transistor can work with high voltage up to maybe 500 volts. So by applying a signal to the base, you enable the transistor, you make the connection to ground, and in that way the number will light up. The problem with this configuration is that you need one BJT transistor for each cathode. So imagine that in my case I have to control 11 pins or 10 pins. So that means that I will need 10 transistors for each Nixie tube. If I want to make my watch with 4 Nixie tubes, that means that I will have to use 40 transistors, each one with its resistor. And not just that, this smartwatch is using the Atmega 220 microcontroller, which has up to 15 digital pins or 16 digital pins. So you will need one pin to control each transistor. So I don't have 40 pins from the microcontroller. So in that way, I'll have to find a different solution. If you want to control only one Nixie tube, you can do that with the Arduino and some NPN transistors. You add one NPN transistor between ground and the cathode of the Nixie tube. You add a resistor to the base of each transistor, and then with the digital pin you can control each one. You can buy a module which will convert 5 volts to around 170 or 180 volts and apply that to a resistor to limit the current, and this will work just fine. But in my case I want to control 4 of these and also not have this much transistors on the PCB of my watch, because in that way the PCB will be very big. So for that I'll use a different approach, and that is using a driver, something like this one. If you remember, this is a 7-segment display, and this driver what will do, each of the LEDs inside of the 7-segment display is connected to positive. But the other side of the LED is connected to this driver, and this internally will make the connection to ground. So we need something like this, but instead of using up to 7 volts, I think this is for 7 volts, instead of working with up to 7 volts, I want to work up to 200 volts. So for that I just had to find a different driver, which is the driver that I will show you right now. Okay guys, so this is the driver that I found. I already bought it, but I haven't received it yet, so I will prepare that for the future video where I will make the PCB for the watch with Nixie tubes. And this is called HV5812WG. This I think is from Texas Instruments, and as you can see it has the input for VDD and also ground, and this is controlled with a serial in. You can control the clock and data pins, data in and data out, and just sending serial data you can control each of these outputs. Actually these are inputs because this is connected to ground. So by connecting the cathode to each of these pins, for example this output 1, this will connect it to ground if you will send the data in the serial way from the Arduino. So in this way, as you can see here, we can use just 2 of these drivers to control 4 Nixie tubes, because each driver can control up to 2 Nixie tubes, because it has I think 24 outputs or 26 outputs. So in this way the circuit will be a lot easier. I will only need 2 pins from the Arduino for data and clock. And also the interesting thing about this driver is that the data out from one driver can go to the data in of the next driver. So only with 2 pins connected from the Arduino to the driver, I can control all 4 Nixie tubes. So this is the circuit that I will use. I'll put some schematics below with the final schematic for my watch. But have in mind that I don't have that PCB yet, and it will be ready in a few weeks, so stay tuned for that. Okay guys, so for the high voltage, this is the circuit that I've prepared. This is actually the same circuit as a boost converter, the boost converter that we have seen in a previous video with Arduino. As you can see, we have the coil, we have the MOSFET, which is our switch, we have the output diode, and the output capacitor, which must be in this case of high voltage. But instead of making the switch with an Arduino, I'm using this IC, which is the MAX1771, which is this one here that I've just soldered with some thin wires to some pins in order to place it on a breadboard and make some tests. We make the configuration with a small resistor to measure the current. We also place some capacitors, and then this will apply a PWM signal to this MOSFET, create the oscillation, charge up the coil, and that will boost the voltage to around 180 volts. So I have this exact same circuit because I bought this module here from eBay. This cost me just $1 or $2, and this uses this exact same circuit with the same IC, and it's a boost converter from 9 volts to around 200 volts. So what I want to do is to use this exact same circuit, but maybe with a different coil to be smaller, and also different output capacitor, maybe an SMD capacitor to be smaller and fit well on my PCB. So what I will do is to place this circuit on my PCB together with the real-time clock, the Arduino and the Nixie Tube drivers, and in that way I can control my Nixie Tubes with high voltage. So this is the circuit that I will be using, and by the way, you have the schematic for this module here below in the description if you want to see it, and all that I'm showing this in this video, you will have it documented on electrons.com with this circuit, with the circuit for the drivers, for the Mega chip, and everything that I will use in a future project to make my watch with Nixie Tubes. So check the description if you want to see more, because in this video I won't show you more because I don't have the PCB yet, which will arrive maybe in a few weeks when I will have it finished. By the way, this IC, as you can see here, has a pin which is called SHDN, and when we place this to high, the module will be in shutdown mode, and when we place it to low, it will be in normal operation. So the idea is that when you don't show the hour, so the Nixie Tubes are not turned on, you can shut down this module so you don't have the high voltage connected all the time. So this is nice because you can connect a digital pin from the Arduino to this IC here, the MAX 1771, and only when you turn on the Nixie Tubes you will turn on this circuit as well. That's pretty great. So I'll do that in the final schematic as well. So guys, let's see everything that we need to make my watch, but with Nixie Tubes. It will be a PCB like this one, maybe a little bit bigger. This is the PCB from the previous watch, which is using an OLED display. But of course on this PCB I'll have the Mega chip from an Arduino to control everything. I'll also have my battery connected to this charging module. This exact same circuit, I have it here with a USB input, and this will offer protection and limits for the charging battery. So I can charge the battery with a USB connection. Then I will take the circuit from this module here, which is creating the high voltage, and place it also on my PCB. So with that we'll have the high voltage for the Nixie Tubes. Then we'll need two drivers. These are not the actual drivers, I just placed this here, but the drivers that I've already ordered are not here yet. It will be in an SMD format, so it will be placed better on the PCB. So with the drivers we can control up to 4 Nixie Tubes. We need the Nixie Tubes, 4 in this case, and also the real-time clock, and this is the DS3231 I think, and this will give me the time, the day of the week, the hour, the week, the month, and so on. And this works very well with the Arduino with an I2C communication. So all these modules will be placed on a PCB. And not just that, but as you can see, if I have my PCB like this and I will place the Nixie Tube like this, if the PCB is horizontal, I will need a vertical connection to the PCB. So I'll try to make another smaller PCB connected only on the Nixie Tube, and then perpendicular to the other PCB will make the connections. So each Nixie Tube will have its own small PCB connected to the main PCB of the watch. So this will be quite difficult. So this is everything that we'll need for my project. I will keep you posted. You have everything that you want to know, the schematic, all that I'm planning to do on electrons.com below in the description. So once I have everything, once I have the PCB, I will make another video and keep you updated. I'm pretty sure that we will have a lot of problems, and we'll talk about that during those videos. So stay tuned for that. Now let me just show you another example. I'll make the schematics for the BJT transistors, and let's control the numbers of one Nixie Tube, because that will look great. As you can see, I've connected this to some pins so I can connect it to my breadboard, and I will make this schematic here. Very simple, with some BJT transistors, only one Nixie Tube, the high voltage transformer, the high voltage module, and the Arduino to control the base of each of the BJT transistor. So let's see an example of how to control each of the numbers of the Nixie Tube, because that will look awesome, and with that we can end this video. So there you have it, guys. I have my high voltage supply here, which is connected from my power supply, and then I feed that here into the circuit, and I have a BJT transistor for each of the numbers of the Nixie Tube, and I control each of the BJT transistors with my Arduino and a small resistor to limit the current. And I upload this code here, which will control each of the segments, each of the numbers inside of the Nixie Tube. So let's see that. There you have it, 0 to 9. Let me just make a zoom in and also maybe increase the speed a little bit, not every second. I'm uploading a new code that will be faster, and there you have it. As you can see, we have that beautiful vintage glow. So that is easy to control these Nixie tubes. All you need is high voltage and control that with some BJT transistors or a driver, in the case of the future project with the smartwatch. So there you have it, guys. Now you should know how to control these Nixie tubes and also how a Nixie tube works internally, more or less, because I didn't go too much in depth with the physics. But anyway, now you should know that we use electrons, we use the neon or mercury gas inside, and so on. But at this point you should know that this works with high voltage DC. So I've shown you the circuit that you need to make to get that high voltage DC and also the driver for the boost converter, then how to connect that to the Nixie tube and how to control it with BJT transistors, which is not a good option because you need a lot of connections for each cathode. So the better solution is to use a driver. I've also shown you what driver you should use to control these Nixie tubes, actually to control two at the same time, and do that with the Arduino. So in the future project we will see how to make my own smartwatch. Actually is a watch, in this case it won't be too smart, and that will be using Nixie tubes. So stay tuned for that, where I'll show you the schematic, the parts that we need, and the code for the watch. So I hope that you will learn something new with this video about Nixie tubes, and if so, please consider subscribing, give a like to this video, and also if you want to support this kind of projects or the future projects, consider supporting me on Patreon. Thanks again, and see you later, guys. Hey guys, Electronoobs here. Thank you for watching this episode on my channel, and your support is great for me. But if you want to beat this YouTube algorithm, because as you know, teaching and learning videos are not very popular, you can make a stupid or maybe a funny video and it will get viral in a moment. But for us, for teaching videos and stuff like that, it won't be very easy to get over this YouTube algorithm. So please, maybe you will leave a comment below, maybe you will give a like and subscribe and also activate the notification bell, and like that we will win this YouTube algorithm. And by the way, if you want to also support my projects, your comments and your likes are very well welcomed. But I'm also on Patreon, so you just click the link below for patreon.com/electronoobs, and maybe you can select one of the tiers. And by that you will be able to see my videos before the YouTube release. You can comment, you can get the files for my projects, and depending on the tier, maybe even receive a t-shirt like this one. And yeah, thank you very much for your support, and I'll see you in the next project. Keep up, you guys.